Hey there everybody, this is winK from winK University, and I'm excited to be here with Bug Crowd today to talk to you about some of my favorite vulnerabilities, the broken access control or insecure direct object reference vulnerability, which sounds way more complicated than it needs to be. First, a little bit about me for those of y'all that haven't heard of me. I'm just a lowly hacker, and I hack almost exclusively with Bug Crowd. And I started back in November of 2020. I've only been at this for about a year and a half. But I have really grown to love it. I just participate part-time, but have found great success very, very quickly with it. And to me, it's more of a hobby and entertainment than it is like, does it feel like work, you know? So I like doing it because it's fun and because you can make a lot of money with it. And that's kind of my drive for doing it. And I think a lot of other people maybe do it just to make a living. It just depends on what your goals are for why you participate in bug bounty. But one of my favorite bugs to hunt, like I said, this insecure direct object reference. It sounds really complicated, right? Like that doesn't make any sense to anybody that isn't in this world already. What it really means is that you're switching an ID with another ID. So like, Take this for example, and I love starting off with this particular example for how to explain this bug. Let's say you go to, and I'm just clicking tabs because I've got ADD. Let's say you go to a bank and you want to get some money out of a bank, right? Well, you go into the bank and the bank teller asks you, oh, hey, welcome to the Bank of Awesome. I know you want to get some money out. Can I see your ID? So you take out your ID, which has your picture and your name on it, and you show it to them. And the bank teller looks at the ID and says, well, yeah, that is you, isn't it? It's got your face, looks like you. Okay, cool, thanks. How much money would you like? And the person that wants the money, you, I guess, is like $10,000. That'd be wonderful. So then the teller's like, cool, what's your account number? And you're like, my account number is 12345. And then so the teller's like, okay, 12345. Yeah, that's there. Cool. Here's $10,000. Thank you. Have a good day. The issue there is that the bank teller, while validating your identity, like you are who you say you are and that you're authorized to be in the bank, neglected to check and see if account 12345 was actually your account. And therefore, you were able to withdraw money from somebody else's bank account. Now, while that sounds ludicrous, like that would never happen in the real world, it actually does more often than you would believe. And the root cause is that the authentication system on websites, right, that between you and the website, you've logged in, you've entered your username, your password, you're authenticated, and the website's like, cool, you're logged in, you've got permission to all the stuff and things. But the server doesn't check that the stuff and things that you're requesting back are actually yours. And that's how an insecure direct object reference happens. If you're user number 1234 and you tell the server now that you're logged in that you want user 12345 and it sends you back their data or you're able to do something with it, well, that's an insecure direct object reference or what I like to call an ID substitution attack. So I've been working with the Pinterest program for, I don't know, off and on a couple of weeks now, probably 2.5, 3 weeks. And I've logged 43 bugs with them, which is what this is right here. And Pinterest is a public program, and public programs are usually very, very difficult to hack, I think, compared to private programs because more people have access to them, they've been around for ages. Public programs can often be more difficult or at least more intimidating. But in my experience in these last couple of weeks, it was absolutely fabulous because Pinterest relies on IDs for every object. Like you have a user ID and a pin ID, and then your pin, when you pin something, belongs to a board which has an ID. And then when you're signed in, you have a customer ID or a business ID or an advertiser ID. And then you have campaigns and analytic IDs. And so it goes on and on and on. And there's like 20 different ID types, and they all use numbers like 1, 2, 3, 4, 5 or 5, 4, 3, 2, 1. There's no complexity to them at all, and they're sequential. So honestly, Pinterest was one of the most fun targets I've worked on in a while. And that's why I have it up. It's a great example of how to hunt for insecure direct object references. And while it wasn't like easy or anything, but it was a target that catered to what it is I like to hunt for. So I went kind of deep on it, and it was really fun. But before we get into that, right, before we get into looking at Pinterest, I want to go through an actual example of, an IDOR in a lab environment. So what I've got pulled up right here is, apparently the Pinterest documentation, but apart from that, we're going to go back to that. Portswigger Web Security Academy is a wonderful tool for getting to learn the basic vulnerability types and practice them in a safe working environment. So you can create a free account on portswigger.net, and this was one of the tools that I used to learn what I was doing back in the day, and I wish I had gone through all the labs, but I didn't. I just sort of toyed with them. But what we're going to do here is click Access the Lab. All right, so we're going to do that. Dun, 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 dun. And when we do that, it's going to take us over to a nice, safe lab environment. Now, this is a lab that is meant to teach insecure direct object references, at least on some level. I don't know exactly what level that is, but what they do is they take you over to this nice, safe domain. This is your little personal virtual environment, so to speak. And what we want to do is scope Burp Suite real quick just to pick up this traffic. So I'm going to come over, and while we've got Pinterest in there already, which I'm going to show you here in a bit, I want to go ahead and add Web Security Academy /web-security-academy/.net. And now when we refresh this page, we should be getting the traffic for it over here into Burp. If all is well and everybody's happy this morning, and maybe I have the proxy turned off because I do that sometimes. Oh, I have the proxy listener turned off. You know, you can't find good help these days. So what we're going to do, we're going to go to Target, Scope, nope, proxy, nope, I'm having a moment. There we are, and we're going to check that little box. What? Failed to start proxy service. Oh my gosh. Well, that was cool. Turns out I actually had 2 copies of Burp open. All right, let's do that again. Ha! There we go. Intercept is off. Now we're getting payloads. All right, and we're cooking with gas. Now, so what we're going to do is just look at this lab for a second. Whenever you get on a new target and you're hunting for anything, whether it's insecure direct object reference or cross-site scripting, or whatever your favorite vulnerability type is, you need to click all the things, right? You've got this GUI exposed that the developers have so kindly given you. So, the thing to do is pick your favorite image, like a person suspended in midair over a set. That person's just nuts. And click View Details. And so, that's all you can highlight. There's no other buttons on the screen. We click that. Let's go back. Let's go home. Let's click My Account. There's not a lot of buttons on this little test website here, right? Keeps it simple for us. We've got a login dialog. We're going to just do test. So we do a log payload there. And then we're going to click Live Chat. And looks like there's something that says you're now chatting with Hal Pine. Your message, hello Hal Pine. This is winK. Yes, send. Now, there's also a View Transcript button. Let's click the View Transcript button because that will make another call somewhere. I don't know what it does. Okay, I downloaded a text file to my computer. Let's open that. Connected, now chatting with Hal Pine. Hello, this is winK. Hi, blah, 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 blah. Okay, cool. So we've used basically every button I see on the screen here. So now let's go back over to Burp Suite and see what we've got. Okay, there's our lab environment. Okay. Let's go ahead and get rid of all the unrequested items. So we're going to say show only requested. Unrequested items show up in gray and they can clutter up the screen sometimes. So here's what we did. All right, so we clicked My Account to look at the products, right? And then we clicked the login page. Then we made a post to the login page with our username and password down there, test. And then we clicked the lab header. Then we went to the chat page. Then we posted a message to the chat dialog right here, as we can see in the screen. And then we apparently downloaded a transcript with the name 2.txt. Now, insecure direct object references do not have to be like, I guess, straight numbers, so I'm going to go ahead and bring this over and show you this here so we don't get too far ahead of ourselves. But what I did was I went back through and audited some of the insecure direct object references, again, ID substitution issues that I've logged over the last year and a half. And I've got a couple $100,000 of these logged, believe it or not. So they pay a lot of money and they vary in severity. So let's talk a little bit through that before we complete this lab and go any further. So whenever I'm testing for these issues, the thing to do is to have 2 completely different accounts created. So you want to have one account that's you might call it your main account, and it has its own set of ID values, right? So you'll have email1@email.com, and it'll have its own IDs assigned to it by the system that you created it in. Then you'll create another user account with a different email address, and it will get a different set of ID values, or username, email address or username, depending on how the system works. And now you've got 2 accounts that you own that you can safely test with, okay? And that's good because when you're testing these ID substitution issues, making put request, post request, patch request, and delete request can be destructive and change the integrity of somebody else's account. if the issue is real. And you don't want to do that, especially in production environments. So it's better to test on your own test accounts, okay, if you can. And you know, and if you're not sure, err on the side of caution. I'll go a little bit more into that here in a little bit. What we've got here on the screen is just a subset of different IDs that I found, and there's a lot more than this. I didn't go through my entire list, but you know, the big ones are going to be things like user account, user ID, and account number. Like you see those in almost every system, right? User ID, account number, profile ID. Those are very common. Phone number and email address can also be things that you could substitute for somebody else's and get different data back. Last name, sometimes in search filters or APIs, all you need is a last name and you'll return other people's data. Other examples you can read yourself: coupon codes, consumer IDs, advertiser IDs, business IDs, social security numbers themselves. Some systems, if you type in a social, it'll return back the data for your social security number, and if you type in somebody else's social, it'll return back the data for their social security number. So what does that mean? Well, that means if you just randomly, arbitrarily loop over social security numbers because they're only 9 digits or something, and you get somebody else's data back, well, that's a data breach. So those are P1s, right? Premise IDs, that's like a location. Itinerary IDs and confirmation codes, things you get at like hotels or spa reservations, whatever. Ticket IDs, policy IDs, bank account numbers. You get the idea, right? Even a VIN, even a complex long ID like a VIN can be an insecure direct object reference, okay? So keep these things in mind. It's basically anything that refers to an object that you can change and get somebody else's data back, or change somebody else's data. Now, back to our lab here, we have 2.txt was the name of our file. So let's send this to the repeater. I usually just right click, send to repeater. I do most of my testing right here in the repeater, and I will get sometimes I'll get hundreds of tabs in here. It gets cray. So this right here is an object, because we're telling the file system to retrieve file number 2.txt. The entire file name itself is technically the object, but more often than not, in a case like this, you're going to see the number itself being iterative, right? So the first chat session was maybe 1, the second chat session's 2, the third chat session's 3, and it goes up like that. So if we change it to a 5, just to be weird, and send it over, we get back the error no transcript. That makes sense, right? Because probably there haven't been 5 transcripts yet. If we send it back to number 0, and remember, we just tinker, right? That's what we do in cybersecurity. We get no transcript. What happens if you give it a negative value? Does it blow up? No? Okay, so ours was 2. Let's try the number 1. Okay, cool. So we got number 1. It says, now chatting with Halpline. Hi, Hal. I think I forgot my password and need confirmation. Sure, no problem. You seem like a nice guy. Just tell me your password and I'll confirm whether it's correct. Wow, you're so nice. Thanks. Okay, my password is that. So there you go. This is a great example of how you can get sensitive information back from an insecure direct object reference. This was somebody else's chat message, and all I had to do was change the number 2 to a number 1 up here and get it back. Now, should the person have actually sent their password in plain text? No. Should the server have actually logged the password in plain text? No. Should the server have maybe checked whether or not I have access to this transcript? Yes. But that's why these things happen, right? And as I explained, I'm logged in, right? I am logged into the system. That's why I have a session ID, or at least I have access to the system. I don't think I logged in, but I have access to it. And then now it's not saying that I have permission to access this transcript. Well, this is a design flaw anyway, because the transcripts are unauthenticated. And since the transcripts are unauthenticated, there's no access check to perform. So really, this is just not a good system, period. There should be complex IDs or encrypted IDs or some value that requires a hash signature that expires or something like that to retrieve these documents back. This is just the way things were done in like 1987. So that's just kind of the example here on the Port Server Web Academy. Now, if we go over to, we go back over to Pinterest, as I was talking about, we see as you're using the Pinterest software, calls are made to the APIs. And, so you're clicking through Pinterest.com, you're looking at pins, you're looking at boards, you're commenting, you're like, oh my gosh, that's the coolest swimsuit I've ever seen, or whatever people do on Pinterest. I don't know, I'm not a user of it. It makes all these calls. So as you're looking here, even in the URLs, you can see that there's these ID values in the path parameter. All right, so let's look at these and talk through it a little bit so we understand what's up. And I'm gonna pick a GET request here first. And for those of y'all out there that think you're clever or whatever, this is from a session from the 27th of May. So if these cookies still work, you are more than welcome to use them, but I'm gonna go out on a limb and say they're not going to. Send a repeater, and GET request. Okay, so the first type of insecure direct object reference testing that I usually do are the GET-based requests. A GET request is doing exactly what it sounds like in almost all cases. It is just retrieving data from the system and bringing it back to you, okay? Now, a GET request in this sense is saying, let's get the version 4 ads API, the advertisers folder, and then I'm going to refer to this ID right here as an advertiser ID, and then I want to grab the custom columns for that advertiser. Now let's go ahead and send that, and it should say authorization failed. Perfect, proof that my cookies don't work. Doesn't matter, we're not doing real testing here, I'm teaching you about IDORs. So what you would do here to test this is you would change this to another ID value that either you know, because it's a GET request, right? That either you know, because you make 2 accounts when you create, when you get onto a target, you create 2 accounts so that you already have a second number that you know, or you can try to iterate the IDs and see if they're sequential, or otherwise you just have to get lucky in this case because it's a really long number, right? Like that's what's that? 1 million, 1 billion, 1 trillion? I don't know, something like 1 trillion numbers. So what I would do in this case if I were just iterating these is I would just loop over the last 4. Now let me show you this exercise. You do get on target sometimes when you don't have a second ID value and you need to be able to prove this vulnerability. So what we do is we right click on this and we send it to the intruder, okay? And I do this a lot, and you hit clear the little $ signs that aren't $signs. And all you gotta do is highlight these first 4 numbers right here and click add $sign. Really fun stuff. And then we come over here to payloads, and you change it to number right here. You say numbers. Now what it's doing is it's saying from 6149 to something. Now, here's the way my brain works. Assuming these things are sequential, all right? Assuming these are sequential, when I created this account, I had the highest number of this account when I created it, which means if a whole bunch of other accounts have not been created since, I might actually be the most recent account. Therefore, looping upwards in count may not actually find a new ID. So, to err on the side of awesome, I actually loop backwards. So instead of looping from a number to a higher number, I loop from a number to a lower number, like 0. And I'm going to do a step of -1, which tells the system to go backwards 1 integer each step. And then I tell it a minimum of 4 digits and a max of 4 digits. So what that's going to do is make sure we have 0, 0, 0, 0 instead of just 0 there. So if I hit start on this now, what you'll see is Burt popping up on my other monitor. And let's go ahead and pause this. And as you can see, it's counting down now the integers really fast, and it's telling us whether or not something happened. Now, were we authenticated and had a valid authentication token? If this were working, what you would probably see is 200 response code for any of them that were valid, and you would see a 401 or a 403 for any that weren't. So the status code is the most important field to look at when you're doing this, and this is a really quick way to try to find another account and see if you get other data back for it. All right, cool. So let's discard that. So that is one way to sort of do batch testing. But again, it's good to have multiple ID values that you can just copy and paste right there yourself and do the testing. Now, this is called a path-based, a URI path-based object reference. Okay, so this is in the path of the URI. Now, you also see them as parameters. And I think I saw one over here. Yes, right there. Let's go send this to the repeater now. Very similarly, you will also see them as parameters a lot of times in the request. So it's always good to do the testing on the parameters as well. Now, what you'll also see sometimes on targets is nothing at all. It'll just say adds internal preferences like that. And what you can do is you get a sense of, through testing the target, the types of parameters that it uses. Like we know that it's using advertiser ID to call advertiser IDs. Like it's called advertiser underscore ID. And we see that over here, we see it over here, we see it over here. Well, then there is some amount of probability that you can probably add the advertiser ID parameter to other requests where you're not actually seeing it, and it will do a lookup on the advertiser ID. Just because you don't see a parameter on a URL call, so especially APIs, doesn't mean that it doesn't support it. See, right here we have a users equals parameter with 1 value. But what's interesting is it's users plural. So what happens if you do a user ID parameter, comma, another one, right? So part of IDOR testing or ID substitution testing is also trying to find hidden places where the values are accepted and you can change them. The more hidden of a vector you can find, the more likely it is to be a valid issue because less people have probably found it. So you have to be creative with looking for them sometimes too. So, keep that in mind. Keep an eye out for parameters and populate yourself a list that you're keeping track of parameter values, and then use that list to try to brute force parameters on other endpoints, okay? That doesn't always work, but it sometimes works. I'm trying to look for an example if they have one that has both. Yes, beautiful. Sender repeater. So on this one, we have both a path object and we have a parameter object. Now, these are interesting because it's usually only obeying one of them, or it's only doing a security check on one of them. And so you want to test them both simultaneously and individually to see what happens. So you would change this to another ID, send the payload, see what happens. Then you would put this back how it was, change this to another ID, send the payload, see what happens, and then change them both at the same time, send the payload and see what happens, okay? And because this one's just using advertiser, not advertiser underscore ID, so see the parameter value is a little different there too. And you gotta send the values and see how they wiggle. Now, that's essentially all there is to it for testing these in GET requests. The key is finding them. Again, the key is finding them. You need to use every single button you can find in the software. And people skip over the buttons all the time. They get to a credit card dialog and they leave it. They don't go any further. Or they'll get to an add bank account dialog and they leave it. They don't get any further. If you can, get a test credit card, get a test bank account, get anything you can, especially the financial stuff that you can to test the system deeper, because most hackers will not enter financial data to test those parts of the system, which is ironic because those parts of the system are actually more critical. So, it's something to think about, right? If you get to a point when you're testing and you think, wow, I don't really want to test that. Ask yourself, I wonder if every other hacker thought that too, and maybe that's an opportunity for me to find something they didn't, okay? Just saying. Now, those are GET requests. The other type of requests you're going to see are things like posts, okay? Now, let's go ahead and send this one to the repeater so we can look at it. This is a post request to an advertiser ID. But there's also, let me go ahead and send this so it makes it pretty. There we go. So there's also a ID down here in the payload body as well. Now, like I said, post request, put request, patch request, and deletes. And you see this up here, right, in the headers. That's the type of request it is. Those are requests that are designed to change something more often than not. It's going to send data to the system that may change a user account or change a profile or change something, delete something, right? So that's called an integrity impact. And when you're testing these, you absolutely do not try to loop over somebody else's advertiser ID and send these requests, okay? Because you might accidentally change a real person's data out there. And you might be thinking, well, I don't care, they shouldn't have let me. Well, don't test like that. We're white hat hackers, okay? We're not out there, we're not gray, we're not black hat. We're just trying to find bugs, help companies get paid for it, okay? That's kind of the recipe. Find bugs, help companies get paid for it. That's it. That's what we do. So you're not helping a company very much if you're finding bugs, breaking people's account, getting paid for it. That's the wrong step. So again, have a second account that you own so that you can test these type of vulnerabilities. So what I would do here, I would change this number to the other account that I own, and I would see if it changed something or brought back data for that other account. And you want to have two browser windows open when you do this so you can log into the second account and look in real time and see if its information has been modified. And that's how you know it's working, right? So you would be logged in as account 1 right here with account 1's cookies. You would change the IDs to account 2's ID values, and then if on account 2 you see a change based on what you did, you know that you have an IDOR or ID substitution issue that has an integrity impact. Integrity impacts tend to be lower, honestly, in most cases, unless it leads to an account takeover or a password reset or some kind of functionality that, worst case, normally it's a denial of service, right, which is a P2, assuming it's critical and easy. But if it leads to account takeover, you can get a P1 via integrity impact sort of IDORs. But the ones I like to hunt first are the GET request-based IDORs because they tend to bring back bulk PII, like personal identifiable information for people, like credit card numbers or account numbers or bank account numbers or driver's license or social security or date of birth or email or phone or address or name. All these things are potentially bad for companies, especially when you can get them in the number of millions, right? Now, Once you're done testing these individually one by one, next step, I normally look for API endpoints or docs, or I go to GitHub or the Wayback Engine or the search engines, and I just try to find any other URLs I can. What I want to show you on the screen next is an API doc that I found for Pinterest. You won't be able to access this, so enjoy. But I had to do a thing and a stuff to be able to even get into this. But let's just say that they exist. And when you find something like this, right, where you have just thousands and thousands of API endpoints that are listed and all their functionalities and everything, this is just a V3 user's endpoint. What I do is I highlight it just like that, okay? And I'll come over here, and let's just do it in here, and I'll paste it into Notepad++. I really love working in Notepad++. It is my jam. I use it all the time. And what I'm going to do is I'm going to do a find and replace, and I'm just going to put a space in, and I'm going to hit replace all. You need to learn how to do things efficiently like this to be able to get the most out of your testing time. So I'll now put in the word put and hit replace all, and I'll put in the word get and I'll hit replace all, and I'll put in the word post and replace all, which I think just leaves delete and then replace all. And now what I've got is a nice clean list of URL stems, less the commas, replace all. I said comma, not period. There we go. And so now we've got this nice, beautiful list. Now, anywhere in this particular syntax where you see user, what we can do is just take that and change it to 1, 2, 3, 4, 5, or whatever a user value is, right? And these look like they're user values too, right there. And followee would also be a user value, and reported user would be a user value as well. So now we've got this nice list pre-populated with user objects that we can go and sort of test and batch real fast, okay? So I'm gonna copy that and show you how I do this. We're gonna go back to our intruder, and all we have to do is you take any given request, you send it to the intruder, and you highlight the URL stem right here, okay? Just hit add little dollar signs that aren't dollar signs. We come over here to payloads. We gotta set it back to simple list, which is the default, and we just hit paste. So now we've got 101 pre-populated V3 users URLs already in here. And all we got to do now is just uncheck URL encode these characters so it doesn't URL encode slashes. And we hit start, okay? And we're going to get a 401 on all of these because I'm not actually authenticated. But the point being is that you saw it just tested 101 URLs for us in like, I don't know, really fast, right? And when you're doing this, like I said, the status code is the #1 thing you're looking for. You're looking for like 200 response codes indicating that your cookies work to return some other user's data. But I want to caveat that and say, remember, automation lacks the context to understand that a 200 response code is not necessarily bad. For example, boards. This would have returned a 200 response code for another user. I know it does. And that's okay because Pinterest wants you to be able to see another user's boards. Automation doesn't understand that. It's going to flag it immediately and it's going to say, this is a vulnerability, go get paid for it. But the human brain, because we're brilliant people, right? We go in there and we say, oh, that's just a Pinterest board. Pinterest wants you to be able to see that. That's not an issue, okay? But if there was some other particular call in here, like the friends that the user has, which I don't think you're supposed to be able to see, and that returned to 200, now you have an issue, right? You can see a user's friends connections, which is not something that's exposed on the public profile. Followers is who you're following is, but who you're friends with is not. So it's something worth keeping in mind, right? That you need to understand the context of the target and what it is that is valuable to the program that you can log. For instance, if you didn't know that there were public and private boards, you wouldn't know that if you could access somebody's board that was marked private, that you could get paid for it, right? You need to understand the target. So make sure, and this is part of that clicking through the GUI in the beginning, make sure you understand your target and that you're learning all of the options and toggle settings as you're clicking through it, especially the privacy and security settings, so that you understand as an attacker how you can circumvent them. If you know that a pin or a board can be marked private, then you know that you should not be able to access a pin or a private board from a user account which does not have access to it, right? Makes sense. So context is king. I'm going to rip that off from Star Trek, I think, in this particular case. Let's go ahead and close that down. Guys, that is pretty much insecure direct object reference or ID substitution hacking in a nutshell. I mean, you've seen it all right here. The only other thing I would say is that sometimes you have IDs that don't look quite so simple. And let's do a quick example of this. Let's say you had, you see a lot of alphanumeric values like X, Y, 2, J, N, L. I did one of these the other day, okay? What happens here is you've got combinations of A through Z and 0 through 9 in different places, okay? And this may look like something you can't brute force or whatever, but it's actually really simple. Let's just show an example here. Let's just say we keep J and L static and we want to loop over XY2. Just hit add $signs, come over here to payloads, and what we want to do is come down to something called the brute forcer, okay? And all you got to do is change these to all caps. We're going to assume it's case sensitive. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I can't spell. Okay, that's the alphabet. So now all we're going to do is, how many characters was that? Remind me, 3. So for every possible combination of A through Z and 0 through 9, it will try those 3 characters. So that's 46,656 possible combinations. You just keep J and L static to keep it simple at first, and you just blow through this. And chances are, based on the entropy, you're going to get a hit. And if you don't, you just add one more character to it and go with it. It's the whole point of an IDR isn't proving that you can get to everybody's account so much as you can get to anybody's account. So as long as you can get one more hit, and you could start simple, you could literally just loop through the last character, A to Z. That's actually probably what I would do if you had this. I would start with XY2JN. I would come over here to payloads. I would simply take off the 0 through 9, change this to 1, change this to 1. Now we've got 26 payloads. Hey, that's the alphabet, right? And we would try that. If that didn't work, I would grow it by 1, and I would do these 2. Because don't take the time to wait for 46,000 or 46 million payloads when all you needed to do was to try 26 to figure out if somebody else's account was there. Or again, if you have access to a second account that you can create, which is always better, just try to get to that from your other account. But in this particular case, the other day when I was doing this, these were actually flight confirmations, and I wasn't able to create a second flight confirmation. So I only had 1, and then from the 1, I found the payload, and from the payload, I needed to prove I could get to a second, so I actually had to do some brute forcing, and that does come up from time to time. Again, everybody, thanks for listening. These are my favorite bugs to hack. You can make a buku of money off of these, and they're super easy. As you can see, it doesn't require rocket surgery or any sort of super duper programming and hackerisms and things that look really complicated. It's just swapping IDs out, okay? But please, 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 at least try to find them. So I feel like I taught you something. That would be amazing. I'm winK again from winK University. Check out my YouTube channel for more information. I want to give a big shout out to BugCrowd for letting me talk here today. And if you haven't played on the BugCrowd platform, you definitely should, because it is awesome. Have a good one, everybody. Thanks so much.